friend. Welcome to an informative video where you will appreciate the Geographic Information System. But before that, let me first introduce myself. I am Grace A. Salinas from BSCS 3 and RM2. I am currently studying at the University of Science and Technology of Southern Philippines.
So without further ado, let me now discuss the use of GIS to the field of the particulate matter concentration. And here is the journal article I have chosen entitled Geostatistics for Air Quality Mapping, a Case of Baguio City, Philippines. Introduction. Air quality monitoring activities in the Philippines has been undertaken by several agencies to generate significant information in formulating air pollution management and control programs. These are the following agencies who have been actively engaging in projects that are related to air quality monitoring with extensive resources and established monitoring stations in the country: the Environmental Management Bureau, or the EMB, Department of Environmental and Natural Resources, or the DNR, Philippines Nuclear Research Institute, or the PNRI, University of the Philippines Institute of Environmental Science and Meteorology. Baguio City is one of the most polluted city according to Comanda 2018, specifically in the Central Business District. It has been identified as one with the highest air pollution concentration among the urban cities. The objectives of the study. This study aims to determine the locations and distributions of the PM concentrations within the CBD Baguio City. The spatial and temporal variations of these pollutant concentrations are to be characterized using Geographic Information System, or GIS, that is based on geostatistical modeling. Next is the methods and materials of the study. The area of the study. In Baguio City, the possible sources of PM are identified in the CBD are soil sources, soil road dust, resuspension, and vehicular emissions according to Hogarth 2018. This study will focus on quantifying vehicular emissions in CBD Baguio City only. And this map will highlight how these emission sources vary spatially through different temporal scenarios, for example, in daytime and nighttime hours. So the traffic and meteorological data sets utilized in these studies were obtained on 2014. So the simulation period is limited to 24 hours from 12 midnight to 11 p.m. of February 8, 2014. The researchers used spatial interpolation. The interpolation process is implemented using the Kringing method, which is regarded as an optimal spatial interpolation method. So here is the formula of the spatial interpolation, where Z is the measured value at location, I is an unknown weight for the measured value at the location, and N is the number of measured values, and X0 is the prediction location, according to NAS 2009. Spatial interpolation involves search neighborhood, the parameterization, assessment of prediction errors, and comparison of geostatistical models. The search mode is represented by a circle or an ellipse that can be divided into two sectors, from which an equal number of points are selected to avoid bias in a particular direction. Geostatistical modeling. Geostatistical modeling process involves several steps in order to obtain detailed estimates of particular matter concentrations, and particularly at 5 meter spatial resolution. This process is employed in Geostatistical Analysis Toolbox in ArcGIS. Results and discussion. Histograms and normal QQ plots of early simulation results from the dispersion modeling show the spatial distribution of the pollutant concentrations. So histograms is linked with the spatial data showing that figure A has the least concentration while figure B has the highest concentration of particulate matter. The results of the spatial interpolation. Early dispersion modeling results of particulate matter point concentrations spaced at 20-meter intervals show that high values range from 135 to 422 micrograms per meter cube. The dispersion modeling results show general patterns of spatial variations of the pollutant concentrations for daytime 6 a.m. to 6 p.m. and nighttime 6 p.m. to 6 a.m. hours. The pollutant concentrations are evident within 40 meters from the roads and are shown in the same sample data set. From the geostatistical modeling results, Figure 7, the figure A and B, these are the figure 7. Spatial variability of PM10 concentrations is more evident on some portions of the CBD, such as the surrounding areas in the north and the northeast side containing road segments such as the Bukaucan Road, Magsaysay Avenue, Session Road, General Luna Avenue, and Harrison Road. So the geostatistical layers show that trends in early simulations are highly dependent on the emission sources and prevailing wind conditions. Low wind conditions occur in the area, thus there is a buildup of particulate matter near the roads and disperse according to the early average wind conditions. As you can see here, during the daytime, there is a high value of the particulate matter, specifically on this road. Conclusion: the spatial and temporal variations of airborne particulate matter 10 concentrations in the CBD Baguio City are assessed in this study by integrating geostatistics with dispersion modeling results. High concentrations are also evident on the roads with high vehicular emissions, so this observation can be seen in the early simulation results. Spatial variations are observed on roads with high vehicular emissions and in their surrounding areas, which are mostly located on the north and northeastern part of the study area. Temporal variations indicate that, in general, higher maximum concentrations and direction of dispersion is more evident during nighttime hours from 6 p.m. to 6 a.m. Thank you for watching. Please don't forget to hit like and subscribe to my YouTube channels. And if you have any question, just comment down below. Thank you.